Hello again. This is Math 1428 Remote Delivery for April 13th, 2020. So we've already learned about the product rules and quotient rules and power rules, but there are mistakes that students often make. So make sure you do not make these mistakes. The logarithm of the product is not the product of the logarithms. The logarithm of a sum is not the sum of the logarithms. The logarithm of a quotient is not the quotient of the logarithms. And the power of a logarithm is not the exponent times the logarithm. Let's look at another example. Now these are more complicated because they are multiple step problems. So in part A, or example A, what we have is a logarithm of a quotient. So the first thing we do is we make that the difference of the numerator, the logarithm of the numerator, minus the logarithm of the denominator. And then we can use the product rule to change this into the sum of the logarithms. And then we use the power rule to change this one into this, and this one into this, and this one into this. So you see we used all three rules in one problem. Here we realize that the cube root is that expression raised to the 1/3 power. So in this one, first we use the power rule, then we're going to use the quotient rule, then we're going to use the product rule and the power rule, both. And then we're going to realize that the log base A of A is A, so that's going to become 2. And then we multiply through and we get this expression. The last example, we have a quotient. So the first thing is we do, it is the difference of the logarithm of the numerator minus the logarithm of the denominator. Then in both cases I use the product rule. Now in this one it is very important that students realize this minus is this minus, so we're subtracting whatever this is, so these parentheses are important. You will get the wrong answer if you do not do that. And then we're going to use the here we just distribute, and then we're going to use the power rule, and we get this. Again, here are a couple of examples for you to try now or later, and I'll supply the solutions to those examples next time. More examples. Now these are going the other way about. We're starting with an expanded version of the logarithm and trying to get it in a more compact form. So here is the problem that we have. First thing we're going to use is the power rule, and we use the power rule here. We also use the power rule here. Then we're going to use the quotient rule. This expression is the logarithm of the quotient. And now we're going to use the product rule, and we're going to make that be the product of z to the logarithm of z to the 1/4 times x to the 5 over y. And then they rewrote it this way. Here we're supposed to express this as a logarithm of, expressed as a single logarithm. We have the natural logarithm of this minus the natural logarithm of this. That means that this is the natural logarithm of the quotient. But we can factor the denominator and cancel out the common factors, and so what we get is that this is the same thing as the natural logarithm of 1 over x minus 2. Again, exercises for you to try, and solutions provided next time. Example 9, we're using our calculators. They tell us suppose that this is true and this is true. Then here we will use the sum rule, just adding them together from our calculator. Here we'll use the difference rule from our calculator. Here we'll use the power rule with our calculator. Here we will use the quotient rule and realize that the logarithm base A of 1 is always 0. We cannot do 5 because this is a mistake students sometimes made, but the logarithm of 5 is not the logarithm of 2 plus the logarithm of 3. It's the logarithm of the product is the sum of the logarithms. This is not true. And here we simply divide. The error that they're thinking that some students might make is subtract these. We divide, not using any of the properties. Here's some problems for you to practice, and you can get the solutions next time, or you can do them now or later. Last but not least, we're going to talk about simplifying these expressions. We know that the exponential function and the logarithm functions are inverses of each other, so we know that for any base a and real number x, the log base a of a to the x is just x. So the logarithm base a of a to the 8 is just 8. The natural logarithm of e to the minus t is just minus t. And the common logarithm base 10 of 10 to the 3k is just 3k. Here's some exercises to try, and you can test yourself on those. The other way about is here you first take x, do the logarithm, and then you do the exponentiation. Still, they are inverses of each other. So 4 to the log base 4 is k. E to the natural logarithm of 5 is 5. And 10 to the log base 10 of 7t is 7t. Here's some exercises you can try, and solutions next time. So here's a summary of the rules: the product rule, the power rule, the quotient rule. The change in base formula from last chapter, it's proven in this chapter within your textbook, and other important properties dealing with inverses. So now, more than ever, time is precious. Each day must count. Do the math, it will make you strong. And now more than ever, take care.